back. It's been a while since I made a battery. I'm going to try making a nickel iron battery, which is a bit different to how you'd see it on YouTube and other places. So I'll start off with some carbon felt, which I nickel plate. Then I cut little, well, first it's nickel plated like that. Then I chop them into these sections, little round discs. The nickel plating doesn't go all the way through, as you can see bits of grey but not saturated. Probably enough. So an uncoated one weighs 0.2 grams and a coated one weighs nearly 1 gram of nickel on the thing. So it starts with this. It's 1 hour in nickel solution to plate. Then you cut your little rounds out, and then you gotta do the edges again. So I put it in for another 5 minutes each piece. And what we'll be doing with these pieces, so well, let's start with the tube. This is a diffuser which I got off of eBay. I wanted mild steel, but all I could find was a perforated hole, which is like this small, and a tube that actually slides in there and seals up when you got your coffee, your tea or your herbal mixes into there. That's 304, so I can't coat it. I wanted mild steel, but that will do for a test sample. I put a plug in the bottom. Probably should have nickel plated that plug before I aridited it in, but it's got a coating of aridite top and bottom. So what happens is it will be a piece of this coated, put in. This is nickel wire, 0.01, curled up into a little coil there at the end. That will be a contact that sits on top and runs up the tube. Then some nickel hydroxide. Don't know the amount yet, I'll work that out a bit later. And then it will be stacked like that all the way up until you get to a certain amount. These are a nickel plated bolt and a nickel plated bit of steel with another piece of steel with a notch in it to take the wire. Will be fed up through there. So this will be the compression plate. That will go in there. This piece here will be glued in after everything's stacked and filled up and then left over 24 hours to set. Then the bolt can compress onto this thing. To compress everything, it's got to be really tightly compressed so the nickel hydroxide can be sort of conductive. And then the metal side will be a similar setup, but with iron Fe304 in the mix. I'm going to use the same pads as well. And hopefully that will form a part of a cell. Really, you'd want like a group of these as the positive side and a group of these as the negative side stuck together like so. But you need to get some mild steel perforated metal would be best, and then nickel coat it all, because this may not last long. May last long enough for a test example. I could probably cut all that junk off, but it doesn't matter. Yeah, that little piece of wire fits in there. I was thinking about bringing the wire on the outside through these holes, but you got to get that down in there, and that piece comes out. But yeah, I don't think I'm gonna mess around with that. They're just gonna go straight in there, all put on one side, twisted around each other, and pop out the top hole here. Oh, can you see that little notch? So they should come up there, and then I can attach them to whatever alligator clip, or I could attach it to this. I needed to clean this down a bit better. Didn't quite coat really nicely. It was had some sort of metal bluing on it, so I wire brushed it, but only by hand. You can see dark spots. It is conductive, but it may not become conductive later. I was originally going to do the tubing as a conductive thing, but since I can't coat it with nickel, it probably will lose its conductivity and the battery won't show its true potential. That's why I'm using these as little contacts. Alright, I'll start assembling and see what happens. Don't know if it's going to work. Right, I had to reweigh the pads again because I think they were a bit wet, the nickel coated ones. So that was 0.2 grams and that's only 0.24. 2.4. And that one was 0.2 grams of 0.02 grams of nickel. So they don't have 1 gram of nickel. It was the electrolyte, I guess. So right, I've formed them. I've got the tops gluing now with some iridite. There's a nickel disc just under that one with the thread in it. So that's the compression disc. We'll screw these screws in to compress everything so tight. So the nickel side one has 11 little pads, has 0.3 grams of nickel hydroxide on the top of each pad, and a little 0.1 nickel wire curled up to act as a contact on top of the nickel hydroxide, and then the next layer goes on. So all up there's 10 layers of nickel hydroxide, and for the metal side it's 0.5 grams of Fe3O4 on top of the nickel pad, and 0.2 grams of this, these are end mill cuttings. They're like little slithers of metal. They're very thin. On top of the Fe3O4, and then a nickel contact wire goes in, and then the next pad, and we layer them up to that. That's got 9 layers. So let that dry overnight. Twirl up all the little contact wires. Only reason I'm using the contact wires is because I think that housing, because I can't nickel coat it, won't last too long. So we could lose our conductivity if we did it that way. But if it was a metal tube and we nickel plated it, it would probably be fine as the contact as well as the bolts. But we'll do it this way for now. This is only a test pilot cell. You'd have to make like a heap of these, and then you might even want to use something other than metal for the things, but for now we'll see how it goes. The glue's dried. The cells have compressed down to that line. They were right up. So that's a bit of compression, almost half. Both sides are pretty equal. So this one's the negative, that's the iron one. This one has the nickel in it. This one has the nickel in it. So I've got the electrolyte ready. I'm just letting it cool down a bit. 4 mole, no, it's 5 mole of potassium hydroxide for now. Good sign. Voltage is slowly going up. That's just the electrolyte soaking into the cell. So they're at 0.4. So I'll have to start charging. I think you can charge them for a while, like 48 hours, who knows. That's what the document said I read. 48 hours on low charges, because I've checked the voltage. on the document. I think it was like 1.6 for the first 48 hours or something. The document I was reading was suggesting 1.7 volts for the first 48 hours of charge, and then back down. So it's drawing in 266 milliamps, and they're sort of pretty spaced away. There's at least 10 mil gap, which is probably ideal. It could probably go up. I can't see any gassing. We could maybe increase the voltage. And what happens if we disconnect the charge for a second? Oh, I can't, it's too hard. I linked the alligator clip, so I can't do it with one hand. The top of the positive one never glued properly. It's probably why the charge amperage dropped down. It went off in like the first 6 minutes. Had to pop off when it went in the electrolyte, didn't it? Like, the thing doesn't even touch the electrolyte, really. That one's going okay. So it was been on charge for an hour. Might give it a run, see how it goes, because the little disc, the compression disc is still jammed down in there, so there's probably some compression. So I'll give it a test. I'll get back, I'll set it up, and then I'll let it dry out tonight and try to re-glue it tomorrow. Okay, it's had an hour's charge, the lid's popped off, and we're just going to test. It's holding like 1.5, but dropping with no load. Starting the test just for the hell of it. It may never work again. So we're at 50 milliamps. 1.4 volts. Oh, I would have thought that would have dropped pretty quickly. Alright, it looks like there's promise in this cell, so I might stop discharging it, pull it out of there, dry it off, tomorrow glue it better, proper gluing. Yeah, let's hope that doesn't wreck it, because it's looking pretty good. Yep, alright. Yeah, I got it all glued back up. I've poked it down into the mesh more, put a bit around the top, and this time I coated the thing before I inserted it. Alright, so it will form a lip now, so I can't push it out because the glue will go through the mesh and lock it in like that one sort of was a bit better. I think I had more glue on that one. Well, I don't think that one's popping off. I'm not sure. Right, not much electrolyte came out of that when I pulled it out of the liquid. I shook it, but it wouldn't drip. So that's what's coming out now. There's a little bit of dampness at the bottom of that tub. Alright, wait for that to dry. First charge after the little accident. It's been on charge for 5 hours, so it's ready to be discharged at 50 milliamps, just to see what's happening. Alright, I'll let it discharge to, oops, I'm going to have to change this to 0.9 as a cutoff voltage. Okay, I'll get back when this is run down. 30 runs on the cell now. It was charged for 6 hours this time, and it ran for 3 hours, 90 milliamp hours and 119 milliwatt hours. So it's looking around about 10 watt hours for a homemade nickel iron battery per kilo, that is. Okay, the results are in for the nickel iron battery. At the bottom of the cell you can see the excess iron. I don't think you need the iron particles, just the Fe304 will do you the trick. I'm constructing another one. Going to use this PVC pipe with a plug glued in there and a heap of holes drilled randomly. I had this prepared 2 months ago, but the last 2 months I had COVID, and then 2 weeks after having COVID I got influenza B, and I've been struggling ever since. I'm sort of on the mend now. I'm better than I was yesterday and the day before. So the first result charges, charge 1 was 50 milliamps. We're only getting 21 milliwatt hours. That's the milliwatt hours column, milliamp hours, average voltage, run time, and the charge time. So 5 hours on the first charge time, ran for 19 minutes. Average voltage was 1.3, 16 milliamp hours and 21 milliwatts. And as you can see, it's increasing as it goes down through the charges. So we are at charge 20 here, 97 milliwatt hours. And I got a slightly better results now, neater, a bit neater, as neat as I can get. So we're at 21 charges there, and that's 1 hour and 6 minutes, start again, 106 milliwatt hours and 80 milliamp hours on a 5.5 hour charge. I went up to 50 milliamps there on the charge, but nothing seemed to change much. Back to 30 here. Sort of, it's goes up and down depending on the weather. I noticed when it's hot the cell performs really well. At charge 53 or 54 I had to re-glue the negative side plate back in because it popped out. There's the negative side here. It lifted up and lost its compression, so I re-glued that about a couple of days before I got back on the line, and then we're back down. And I upped the amperage, which I increased the voltage on my charging machine to get higher amperage. And we're getting up there now. We're 172 milliwatt hours on that run. Charge time's around about 6, 8, 7 hours. So you can view the records. This is where I got sick. First week on charge after being sick. And down here, we're still in the high range. We got a 179 milliwatt hour run on a 7 hour charge. That was 580 milliamps at charging, 550. We've got 203 there. It's still around the good ballpark. It still works, changes. So total hours of charging on the cell was 624.1 hours. Total runtime on the cell was 359.85 hours, and milliwatt hours 12,773 milliamp hours over the whole thing. It's still functioning now, but I'm going to assemble this one, and I asked ChatGPT about this cell, and it suggests that the compression of this disc is important, not to compress it too much. So on this build, I'll only slightly add the pressure because it needs the electrolyte to flow through the center to increase its power density. So that's what the ChatGPT was saying. It was quite handy actually. It was impressed at using carbon coated in nickel. So that actually took a long hours to coat all of these, and then I started getting this weird issue where the I think it's from the alligator clips going into the nickel solution and contaminating it. But I'm not sure, because that could also be turning to nickel hydroxide, sort of, because it starts off grey, and if you keep it in the liquid too long, it starts turning black. So I've got enough little cutout discs. I'm not going to coat the outside, that's going to take forever. I tried a batch coating in this little cylinder, but it didn't work. So you coat them like this, stamp them out like this, put your little coil on the top, and pack this. And then I'm going to compress it as I go a bit so you get more and not wasting space. I want to fill this tube right up to here. Going to use that as a case. It's going to have a lid. Lid's important too, because I noticed it spits out a lot of electrolyte, and I ended up adding a spoonful to take up all the electrolyte, which actually spilt out of potassium hydroxide, which increased the cell's performance a bit better. So all the way through, the voltage is the average voltage is not too bad, 1.3 to 1.2. 1.4 there, I don't know what goes on. Sometimes the data logger plays up as well. So I'm going to post this. I hope you enjoy it. So if you build one, or you can wait until I finish making that one, where I won't be putting the iron metal particles, because it's not really iron, it's steel, mild steel, so it has other things in there, carbon and other things as well, which the ChatGPT bot also said could interfere with the chemical composition of the whole cell. It would prefer iron. Yeah, so there we go. Okay, so thanks for watching. Hope you enjoy the video. See you on this run.